So what good are these spanning trees? Are they just a mathematical curiosity? Well, it turns out they're used in a bunch of applications. I mean, the most obvious one is the one I've alluded to, which is I want to wire up a bunch of physical objects. So maybe I just want to wire up a bunch of towns so that they can all have power. In that case, you are trying to minimize the total cost of all the wiring. And in real life, of course, you have a little redundancy, so it might not be literally just a tree, but something close to a tree. But there are other less obvious examples that are used all over the place. So a couple that I just found, and these are not things I'm personally intimately familiar with, but here's an example where, and it's a paper from the 90s, where the author is trying to identify handwritten math equations. And what this spanning tree is it's a spanning tree of the strokes that the writer used to write out the equation. So this K up top consists of 2 strokes. The summation symbol is 1 stroke, and so forth. And this spanning tree is somehow helpful in understanding the structure of the equation that the user has written. Another example is in medical imaging. So here, a bunch of nuclei of cancer cells have been automatically detected, and then the spanning tree computed. And I can imagine the spanning tree acts as a high-level, simple picture of the entire cluster of cells. And so you might ask questions like, what is the average length of the line in the spanning tree? And that type of information might be helpful, but they may use it in some other way. Again, these are not my domain expertise, but spanning trees are used in a bunch of places. And there's more here. For example, finding quasar superstructures and more. Okay? But in our class, we're not going to be super concerned with the applications. We're going to be using it more as a math problem, but be aware that it is actually something that's useful out there in the world.